Let us begin with the definition of moment of inertia. Moment of inertia of a rigid body about an axis of rotation is defined as the property by virtue of which a rigid body is unable to change its state of rest or of uniform rotational motion without the help of an external torque. Okay, so this is the definition of moment of inertia, and like I have already said that moment of inertia not only depends upon the mass of the body but also the mass distribution. Okay, not only the mass of the body but also the mass distribution. So if I have to calculate the moment of inertia of a point mass about a given axis of rotation, let's say this is the point mass, okay, this is point mass m and this is the axis of rotation, all right, and this point mass is revolving around this axis of rotation in such a way that its center is lying on the axis of rotation. All right, then we can say that the distance between its center and or the axis of rotation and the point mass is r. All right, then we can say moment of inertia of that point mass is equals to moment of inertia of that point mass is equals to mass of the body and square of the distance between the axis of rotation and the location of point mass. But what if I have to calculate the moment of inertia about an axis of rotation of a rigid body? If we know different masses of this rigid body, let's say a rigid body is consisting of various particles P1, P2, P3, P4, likewise up to, if we have n number of particles, then we can assign their masses also M1, M2, M3, likewise. If we know the masses and if we know the location of these masses from the axis of rotation, let's say R1, R2, R3, likewise, the net moment of inertia, we can denote moment of inertia as I, can be written as is equals to the summation of or the sum of the individual momenta of inertia, isn't it? So this is m1 r1 square plus m2 r2 square plus m3 r3 square, likewise. Okay, or we can write this I is equals to summation m r square. All right, summation m r square. Only when we know individual masses of a rigid body. What if we do not know the individual masses of a rigid body? Okay, in that case moment of inertia of a rigid body which is revolving around an axis of rotation, okay, an axis of rotation, let's say xy, and in anti-clockwise direction, then in such a case we have to divide this rigid body in such a way that each particle is consisting of an elemental mass. Okay, and let's say the elemental mass is located at r distance from the axis of rotation. Okay, then how to calculate the elemental mass? So say here elemental mass dm is equals to, okay, for one dimensional body like a road, for one dimensional body, this elemental mass can be calculated by following this formula: total mass of the body divided by total length multiplied by width of the elemental mass, So this is the formula for one dimensional bodies. For two dimensional bodies, elemental mass dm can be written as the total mass per mass of the rigid body divided by area of the rigid body multiplied by area occupied by the elemental mass. So by following these formulae, we can calculate the elemental mass of a rigid body. Alright, so after calculating the elemental mass, let us calculate the moment of inertia for an elemental mass. So this is di. So this di is equals to, as per the formula, what is the formula for moment of inertia? It is nothing but the product of mass of the body. So here in this case we are taking elemental mass multiplied by square of the distance between that mass and the axis of rotation. So here the elemental mass is located at r distance from the axis of rotation, therefore we have multiplied dm with r square. Okay, so di, that is moment of inertia of an element, is equals to dm r square. So if we have to calculate the total moment of inertia of the rigid body, this I will be is equals to integration di, which is equals to integration dm r square. So here the limits of integration depends upon shape and size of the body or configuration of the rigid body. Okay, like I have already said, you should always remember that the moment of inertia of a body changes with the change in position or location of the axis of rotation. Okay, thank you.